I'll figure this out. Okay. Well, we'll go ahead and get started, and welcome. Welcome back to school. Welcome to UCLA. This is exciting. You guys are on campus. Wait, I guess just show of hands. Who's I guess a first year student? Like you were just admitted in your freshman. Okay, all right. Well, congratulations, and congratulations on. I guess you had to survive your last year and a half of high school online, I imagine, or something. I don't know. Did you guys have an in-person graduation? Okay, all right. Well, that's nice. That's nice. Okay. And then those, who's the second year? Second year student? Okay, all right, well, welcome. This would be your first time on campus, I'm assuming, even though you're a second year student also, as well? Okay, well, I didn't get any. All right, and I'm mic'd up, and I'm sorry for the feedback. I'll figure out the right level of speaking to use. You guys can hear me okay? Those in the back? Okay, all right, well, great. And then I guess third and fourth year students. Is that all right? And so, are you guys majoring in things other than data theory? What are you guys studying? Econ. Okay. All right. I feel like we got a bunch of econ majors. Okay. What's that?
Applied math.
Applied math. Okay. All right. So applied math is also great. So. And then, okay, data theory or pre-data theory, or whatever we call these. Okay, all right, great. Stats majors? All right, our stats major. Okay, I'm from the stats department, so I'm biased towards our majors, I guess, stats and data theory and stuff. Okay. Well, I didn't introduce. I'm Miles Chen. That's my name. So I will be your teacher, and you guys can call me Miles. You can also call me Professor Chen or Dr. Chen, whatever feels more comfortable for you. But that's fine. Okay. So you have to complete the daily symptom monitoring survey every day. That's like one of our things. You have to wear a mask. Everybody's wearing a mask, and that's great. Okay, and then if you're sick, stay home. Okay, even if it's exam day, if you're sick, just stay home. All right, we're gonna go off of trust. All right, I'll work with you to figure out a makeup or something. Okay, and then all of these lectures, I'm clicking record on my computer now. Sometimes something goes wrong, okay, but barring that, the lectures will be recorded, and you can keep up that way. All right, read the syllabus. I think you guys all did that in discussion yesterday, right? And I don't know, I feel like my syllabus is really long, but I feel like it has a lot of good information in there, so I don't know. Thank you guys for going through that and taking. I don't know if you guys had any questions about the syllabus. Yes.
How do we download our studio?
Okay, we will cover that. Okay. Yes. So that's a thing. We'll cover all of that. Okay. You guys should have been invited to Campuswire, and that's kind of going to be our discussion forum. So no need to create like a Discord or group chat or whatever thing people use. I think it's pretty good. It's I'm on there, and then your classmates are on there. Okay. If you can't come live, watch the lecture video, and then I forgot to do this, but. Oops. Okay, and then this last thing, I work much better with office hours rather than email. Okay, I know like people send emails and stuff, and I do receive emails, and I do like read them. It just, I don't know, for whatever reason, it's like it takes a lot of mental energy to like write out a response. Whereas, and it's not that I'm like trying to avoid students. It's just like, sometimes it's easier to just leave a message on read rather than like get yourself the emotional energy to like respond to whatever this person has texted you, right? And that's kind of how I feel about emails. And so I'd much rather you come to office hours. Okay, I hold office hours 5 times during the week. I think that's a good amount, and then I schedule them on the 30s, just in case you have class. It straddles, so like if you have class that ends at 1 o'clock, you can come after 1 o'clock, or if you have class that starts at 1 o'clock, you can come before 1 o'clock, something like that. So hopefully, at least among these wide spectrum of issues or emails, you can visit, or office hours, you can visit me, and I'm happy to try to resolve your issues and things. And if you have stuff, we'll figure that out. Now, I hold my office hours for all of the classes I teach. So just make sure you tell me you're in like Stats 15 or something like that. If you say I'm in your Stats class, that doesn't help me out because all of the classes I teach are Stats classes. So the link for office hours are on thing. They're all via Zoom. And also, like a few minutes after class, I can kind of stick around. Generally, so the way I use email will be like as receipts. So like you come to me during office hours and you tell me something, and then I'll tell you like, okay, I'll grant you, this extension, or we'll do this and that. And I'll use an email to kind of give you a paper trail for like the conversation we had. And then, and that's how it goes. It usually works better that way. So not to say you're not allowed to send me emails. You can send me emails, but just be prepared. It might take a while to get a response if you only send me an email. What you can do is you can send me an email. You can come to office hours and then tell me, I'll resolve your thing. And then you can say, just reply to the email I sent you. And then I'll, generally when I send an email, it's like 4 words long. I'll be like, yes, that's fine, or something, okay? It's not like, hey, how are you doing? And, you're supposed to have all of these pleasantries when it comes to starting and ending an email, but I'm not being rude. I'm just trying to get through the thing. Okay, so, all right, so this is all to say that, right? Okay, you got questions about lecture content, questions about the homework, things like that. I would say Campuswire is probably the best place to go. I'll respond to questions on Campuswire. Your TA will respond to questions on Campuswire. And then each other will be required to participate on Campuswire to kind of answer each other's questions and stuff, okay? Now, Campuswire has this little upvote system. Okay, you can't downvote people's answers, but you can always upvote them, or like them, or thumbs up, whatever they call it. And it costs you nothing to upvote people's answers, but then it gives those people points, right? And we're going to go off of Campuswire points to get credit, okay? And so be generous with your likes and upvotes on Campuswire, right? So I think you guys are familiar with the concept of generosity with upvotes. So just do that. Okay, this is our textbook, okay? So full disclaimer, this is the very first time I'm teaching the class. This is the very first time this class has been offered. But this is, I'll talk a little bit more about it, but this is like an introduction to, I guess, statistics and data science and whatnot, and this is the textbook that we're going to use. It's textbooks are expensive, and I'm sorry about that. Okay, it's like I think it's about $100 for the physical textbook. There is and this is a completely legit. You don't have to have any guilt, right? So I believe authors who write a book should be compensated for their work and stuff. And there's a whole bunch of issues with the textbook industry, but I cannot, with a good conscience, recommend people pirate or illegally download textbooks or something. But the textbook is available for free as long as you read it in your browser, okay? And so you can read the entire textbook. And this is the website of the authors of the textbook, okay? So this is a legitimate thing. It's not some illegal thing that somebody's doing. It's just their way of, I guess, kind of their agreement with the publisher is that it has to be kind of just an HTML thing that appears in your browser, so you can't just like create a PDF and distribute it, right? It's a little bit more clunky, and it's not as nice. And some of you, I mean, I'm a little old-fashioned. I like holding pages in my hand and stuff, and if you're able to do that, and you have the financial means to do it, the textbook, physical textbook, I think is great. But if not, if you're happy with just reading things in your browser, you can do that, right? You can just find it on Google. You just do modern data science with R. You type in the name of the textbook, and then the first link that is not an advertisement is the textbook webpage. Okay, make sure you get the second edition. Okay. Data science is a very quickly evolving field. It's kind of like a new thing, and so like every couple of years, like there's new stuff, right? So, that's what we got there. Okay. All right. I think we guys covered this already in the syllabus, but I'll just talk about some of the stuff. So we're gonna have homework. I will assign homework problems from the textbook, or I'll write some of my own homework problems. Okay. There's also there's going to be Data Camp homework, and I just got the approval from Data Camp to kind of give you guys subscriptions and stuff. And Data Camp, I don't know if you guys, has anyone ever used Data Camp before? No. Okay. So let's go to Data Camp. Okay. So Data Camp is I think it's a pretty good service, and but it costs money. Okay. I think if you were to sign up for yourself, I think it's like $30 a month. Okay. All right. So if you agree to an annual subscription, it's $25 a month, and then I guess right now they have a sale going on and things like that. Okay. If some of you guys are looking ahead to possible careers in data science and things like that, and Data Camp I think is a great resource for training. Basically, you watch like a video, and then you'll get the subscription, okay? And they have these exercises that are interactive and things like that, and it's pretty good. Well, and basically, they have they give students enrolled. So as a professor, I apply and I say, hey, can I get some subscriptions for my students? And then they granted me them. So you will get an email invitation to Data Camp. Okay. Now, what's important is, so the emails I'm going to invite are the emails that are listed on My UCLA or CCLE, just kind of the ones you have registered with the university. So you'll get an invitation at that email address. When you create your account with Data Camp, you have to use the exact same email address in order to get the subscription. Okay. Otherwise, you're not going to get the subscription, and they'll ask you for money. Okay. And it has to be the exact same. So I know there's like at UCLA and then at g.ucla if you use like the Gmail suite and stuff like that. And so whichever one you've used, make sure you use the exact same one. So if what's listed on My UCLA is at UCLA, don't sign up with g.ucla, okay, or and vice versa. So make sure it's exactly the same. Otherwise, you're going to be running into problems, okay? And basically, you'll go on there and you'll do some chapters and things like that. If most of the courses on Data Camp are like 4 or 5 chapters long, I will generally just assign maybe 2 or 3 chapters out of a course, okay? And that will be enough to complete your like weekly Data Camp homework for this class. Now, Data Camp also says like if you complete the full course, you get like this little certificate or something that you can then like put on LinkedIn and stuff like that. And yeah, so up to you. You do whatever as much as you want, and it's a free subscription. So everything actually, some of you might find that you really enjoy Data Camp, and with this subscription, actually all of their content is unlocked, not just the ones I picked for the class. So if you're like, oh, I want to learn Python too, which also I recommend that if you're interested in data science, that you learn Python along the way. I also teach Python Stats 21, which is the Python course. You can do that, right? You can get started on Python and complete their courses, get their certificates. They also have like assessments and exams that you can take and get certificates and things like that. Okay. All right. Lecture viewing quizzes. I forgot. I apologize. I forgot to set one up for today. But I will set it up, okay? I will set it up. And so after lecture is done, what you will need to do is you will have to take the lecture viewing quiz. Now, the lecture viewing quiz is going to be, you'll just see 3 questions. Each question will just say A, B, C, D, E, okay? And there's no context to the question. There's no, the answers to the question will not appear in the lecture notes or anything. Like, you're only going to get it by listening to me talk here, okay? So you will want to jot down right now, at least, or somewhere on your phone or something, the very first question in today's viewing quiz. The first question, the answer is the letter B. The letter B. B as in bear, B as in ball, boy, Bermuda, Bravo, I don't know. Okay. The letter B is the very first question, will be the answer to the first question, okay? And then I'll be sure to give you answers to questions, the other questions, right? Probably 3 questions, right? So I'll give you the other 2 questions as we go through the lecture and things like that. And this is kind of the way, so there's no attendance, right? Like if you can't come to class for whatever reason, there's no penalty, all right? But I do want to make sure people are like watching the lecture content. So again, it's being recorded, and if you can't come live, just watch the video, and then listen for the answers, and then you'll fill in the answers. Okay. The viewing quizzes are due before the next lecture, right? So our next lecture is going to be Monday at 9 a.m. Okay. So it's going to be due like 8:59 on Monday. Okay. And so just make sure you watch it, and that way I can kind of make sure people are keeping up with the material and things like that. Yes, question.
Where do we take this quiz?
It'll be on CCLE, right? So it'll be on CCLE. You'll see it. It'll and I'm sorry, I forgot to post it today, but you'll see it shortly after class. I'll get the quiz posted. Okay. All right, we'll have just one exam, and then we'll have a group project, okay? And so at some point, I'll have you guys form groups, but probably within the first week or 2, figure out groups of 3 or 4 and things like that. Preferably groups of 4, but if you have a group of 3, that's fine, okay? I don't want groups of 5, because I feel like once you get to groups of 5, it's easy for somebody to do nothing and slip under the radar that way, right? When you have a group of 3 or 4, it's harder to not do any work. So, and you being UCLA students, I'm sure you've all experienced in high school being in a group where someone's not pulling their own weight, okay? And generally, all the students who come to UCLA are all the ones that were like, why aren't they doing the work? And So usually the but group dynamics just exist at all tiers, of all schools, and not necessarily because the person's lazy or something, but a lot of times people have things happening in life too that also preclude them from contributing as much as they would have liked in more ideal situations. And so, want to be sensitive and aware of that. Okay. Anyway, we'll give you more information about the group project as we go. And then Campuswire, ask questions, answer questions, upvote each other's answers, and things like that. Okay. And that's it. Okay. I go off of a straight scale. I don't curve grades. If for whatever reason there's like the class is performing very poorly, and I honestly I can't imagine that happening just with the way it's kind of structured, where a lot of these points should be easy. Data camp homework should be easy points. So by the way, data camp, they'll offer if you get stuck on a thing, it'll say take a hint, but then it's like if you take the hint you lose points. Okay, it doesn't count at all towards your grade, right? Take as many hints as you want, right? Use all the hints. That's fine, okay? And it's gonna say you use the hint, you're gonna lose 30 points or whatever. I don't care, all right? I just want you to finish, okay? So use the hints, get through it, right? The whole point of the data camp homework is to help you and give you practice and stuff like this. That's the whole point of all of the homework, okay? It's not like I have fun having you guys do homework or something. It's to help you learn, and see if you get stuck, use the hint, don't feel bad. The data camp is you either finish the homework and you get 100%, or you finished late and you get 80%, or you didn't do it and you get 0, okay? So just make sure you do it, okay? And then the view quizzes, those should be an easy set of points. The homework, we'll talk about the homework, okay? And then, maybe, I don't know. Okay, so there's points in other places, but this 25% of points should be fairly easy to get to max out. Okay, so I don't curve grades. Okay, all right. And again, yes, if you're feeling sick, don't come. Okay, don't come. No penalty for not coming. That said, I do like seeing you guys here. Okay, and I'm very excited to be back on campus and see you guys. Yes, question.
Where do we get the Zoom?
So I will post the video. So I'm recording it on my computer, and I really hope it doesn't crash or break on me. Okay, and then I'll upload them to YouTube, and then I'll put the link on CCLE, and then you can just click and watch there. Okay. It's I guess I could have simulcasted the Zoom or something, but it got really complicated. It's not super complicated, but it's just because Zoom also, if nobody's logged in at the same time, it shuts off the meeting automatically. And so anyway, that's happening. Okay, so I do want to talk a little bit about academic integrity, plagiarism, and stuff like that. And so the truth is, right, is there's a lot of code already out there, and they're freely available. You can search GitHub, there's Stack Exchange, there's different places where people have written the answers and things like that, okay? And when you go out, once you graduate here and you start working a job and things like that, you're gonna be using Google, and you're gonna be looking up answers, and you're gonna say, well, how did people figure this out, okay? And that's totally normal, because at your job, the goal is to do whatever has been assigned to you. Your boss says, I need this done, and you need to get that done, okay? And there's no penalty. At your job, they don't care, did you plagiarize this piece of code? They just want the task done, okay? And so that's fine, okay? That's great if the goal is to get the job done, okay? But in but I want you to remind you, the reason why you're here and you're taking this class is not to get the task done, okay? It's sometimes you feel the pressure because it's there's a homework assignment and you're gonna get points based on the homework. But the goal, the whole reason why we assign homework is because it's practice for you to learn, okay? I don't care. I'm not your boss. I don't care if you figured out how to do this algorithm or not. I mean, like, if the algorithm works or not, I care about your learning, right? Okay? And I think of this a lot, like, working out at the gym or something like that, right? If you think of going to the gym and you talk about lifting weights, okay? The goal of lifting weights is not that the weights get lifted up off the ground, okay? That's not the goal, okay? Because if that were the goal is that by lifting the weights, the process of lifting the weights strains you and then makes you stronger, right? And I think very easily we understand this concept of no pain, no gain. Basically, if you didn't work out hard enough where you got tired or you experienced some soreness, you can't expect to come back stronger, right? If the only exercise you're doing is super easy and you're not breaking a sweat at all, you're not gonna see improvement, right? And similarly, when it comes to learning stuff, if everything you do is super easy, okay, and probably you can recall a time in your schooling where you were in a class and everything was like super easy or something, and you were not challenged, you might feel like, oh, this was a waste, okay? And again, if you don't feel any challenge, it's not a good thing. So when you feel a challenge in a homework assignment or in something, that's a good thing, right? It's putting a little bit of stress, hopefully not like this crazy anguish on you, but a little bit of stress that will make you stronger, okay? And so when it comes to something like plagiarizing, right? If you get stuck on an assignment, I say, figure out this answer, and you get a little bit stuck, I want you to struggle through it rather than going online and searching for answers, okay? Plagiarizing is basically like going to the gym and you're trying to lift weights, and then you say, oh, you know what? I should just have this other person lift the weights for me. And you go, ta-da, weights were lifted, 25 times today. I didn't do the reps, but somebody else did. The weights got lifted, and then it's like saying, oh, well, we did the workout today because the work of lifting the weights was accomplished, okay? But that's silly, right? You guys are laughing because that's a ridiculous idea. That's not going to accomplish the goal, right? The goal is you gain strength by lifting the weights, and the goal of the homework is you learn something by doing the homework, okay? So copying someone else's code is not going to help you, right? And I know sometimes it gets confused because sometimes students see the goal to be, I need to get this good grade, right? I need to get the good grade. And if you value the grade over the learning, that's when you might be tempted to plagiarize or do something where you feel like, oh, I need the answer to be correct versus I need to go through the process to learn, right? And it's just a little bit unfortunate, like, as I say all of this, like, I have to give grades, right? It'd be great if there was no grades and we can just be like, we want to learn and we all are happily do that and stuff. But I do have to give a little bit of grades, and you are ultimately graded on how well you've done the thing. But again, I hope you can go through a class and you can feel like proud of yourself based on what you've learned and not necessarily just what the grade book says at the end of the course, okay? And that requires a bit of maybe a mindset shift for some of you, okay? Okay, but let's talk about this class, Stats 15, Introduction to Data Science. And I don't know, some of you might have wanted to take Stats 10. And some of you, you're taking this class because you're going to be data theory majors and all of that. And so I have a lot to say. And you might say, well, why is it data theory? I don't know if anybody ever gave you a good explanation why it's data theory and not data science and things like that. But maybe we'll cover that. Oh, okay. Let me give you your second view quiz answer. Second view quiz answer is the letter C. C as in cat. C as in cat is your second view quiz answer. Second view quiz answer. Okay, and again, this view quiz will appear on CCLE, and you'll just click in your answers, okay? Now these view quiz answers, they are quizzes, okay? And so it is, it would be considered cheating and academic dishonesty if you share the answers to a quiz with another student, okay? So, and again, you're not doing them any favors. The whole reason why we're having these, I'm putting these quizzes in here, is to just kind of make sure you're like watching the content and listening. And so you're not doing any favors by doing that. And I don't know if there's a way to catch somebody sharing answers other than like blatantly, like, you see somebody's text somebody the answers or something, but it would be considered cheating, right? Just like if you were to share answers to any other quiz, you would say, oh, that's obviously cheating. Sharing the answers to even the view quiz would be considered cheating. Okay, so Wikipedia defines data science this way. It says data science is an interdisciplinary field. I got so excited I bought one of these things. So I don't know what I'm going to do with this, but so yeah, interdisciplinary field. Okay, so that's totally the case. Okay, that uses scientific methods, processes, algorithms, and systems to extract knowledge and insight from noisy, structured, and unstructured data, and apply knowledge and actionable insights from data across a broad range of application domains. Okay, so that's like super, super, super wordy. But indeed, I feel strongly about this interdisciplinary idea, and we'll talk about that in a couple slides here, okay? The textbook, the very first line is, information is what we want, but data are what we've got, okay? And there's a distinction between information and meaning and understanding from what data is, right? So you have data, and that's basically just kind of like numbers or just records stored in some kind of table, and we want to, from that, extract information, right? And so I would say data science and the subject of statistics, and basically our department, is all about finding insight and meaning from data, okay? And I say, today we're living in kind of this golden age of data, right? You guys are all carrying a phone around with you, and you have a computer, and you use the internet, and basically every single thing you do, right? Every time you tap something on your phone, that is being logged and recorded somewhere, right? There's an advertisement, and you click it, and some server is saying, oh, they clicked the ad, okay? And they've got like the advertisement with, the person that looks this way, and the advertisement with the person that looks another way, and they go, oh, they clicked this one. This is the person we need to use, right? And all of this is being recorded, okay? And then the next time they say, show them the ad again, show them with that person again, and holding a different product, and right? So they right? I don't know. You ever read like the news, and at the bottom of the news there's like 8 pictures, and they're all like, what's the word? It's like, I don't know, but they're all like, they put these enticing photos on there, and you're like tempted with all of these like titles, these clickbait titles. They just want you to get to click that thing to show you more ads and whatever it is, okay? And basically companies, not just these websites, are investing tons of money to try to get more data, and they're hiring data analysts and data scientists. Like this is like the hottest job, right? And I imagine a reason why some of you are picking this field, because they realize, oh, you know what? There's a lot of value in this, right? And why is it so important? Because when we make conclusions and decisions based on the data, they're generally more reliable than our decisions based on, say, gut feelings, tradition, or intuition, right? A lot of times the data align with our gut feelings, but sometimes they're a little bit different, and generally when you rely on the data, it's more reliable, right? And data has really transformed all kinds of different industries and how we do things, okay? So you might ask, well, what's the difference between data science and statistics, right? Because we got this class, Stats 15, Intro to Data Science. We have Stats 10, which is basically Intro Statistics, and what's kind of the difference and things like that. And we have the stats major, we things like that. Okay, so what's the difference? All right, so this is also straight from Wikipedia. So you have some statisticians, Nate Silver, who does baseball stats and political stats and stuff. They argued that data science is basically just another name for statistics. And others will say, yeah, data science is distinct from statistics. And because maybe data science is related to digital data. Someone else says that statistics emphasize quantitative data and description, whereas data science deals with quantitative and qualitative data, like images, and a lot of the technologies used for image processing have come to your phone now, right? You take a picture and you can say blur the background, and it's already able to figure out what's in the foreground and what's in the background, and it's like magic. Or maybe it just feels expected now, but that was like a huge breakthrough in data science and image recognition, stuff like that, right? Data science emphasizes prediction and action and things like that. And basically, Wikipedia just comes to the conclusion. It says data science can be described as an applied branch of statistics. I don't know how I feel about that. It's a decent thing. This is kind of the textbook. As you read chapter 1 in the textbook, they talk a little bit about the history of statistics and things like that. And statistics was really born out of a time where it was very expensive to collect data, okay? And so you have people like Francis Galton, Carl Pearson, and Ronald Fisher. These are kind of considered as some of the founders of statistics. They came up with a lot of ingenious methods that allowed them to kind of maximize the information they could get from the least amount of data. So this was at a time where they were doing data based on agriculture. They would have to plant crops, and they wanted to know what was the effect of this amounts of water or fertilizer, things like that. And so they would plant crops, and they would have 25 different fields with each one with slightly different conditions. And then you'd have to wait a whole season, and then you'd harvest the crops, and then you'd measure how much they grew and things like that, right? And so just to get 25 data points, it took an entire year of time and stuff, right? So those 25 data points, incredibly labor intensive just to gather those 25 data points, right? And today, if I tell you, oh, how big's your data set? And you say, oh, I got 25 observations, you'd be like, what are you gonna do with that? But it was coming, and so they wanted to say, well, how can we maximize the information we're getting out of these 25 observations? And so they came up with a lot of these really ingenious things. And at that time, pretty much all of the computations, when you only have 25 data points, could be done by hand. And really, you didn't have the option of using computers and things like that, okay? And the class, Stats 101B, some of you are going to take that and some of you might not, okay? That's design and analysis of experiments. That's really about kind of some of the concepts here, okay? You learn something about the Latin square design and things like that. And it's about, if you're going to go out and gather data, and it's really expensive, each observation, how can you maximize that information, right? And there's still lots of situations where that's the case, right? So for example, if you're doing some kind of experimental treatment for, say, cancer or something like that, okay, just the materials, that medication might, because it's experimental, might cost thousands of dollars just to manufacture that medication, right? There's the monoclonal antibodies and stuff used as a treatment for COVID and stuff. That's an experimental thing. It's very expensive. Plus, in order to provide that treatment, you need to have trained nurses and doctors, and so you have to pay that staff. And basically each observation is going to cost you thousands of dollars just to get one observation and maybe a few measurements there. And so obviously when you say, I want to do this study, and they say, well, how much money do you need? And you say, well, I need $10 million. They might say, well, please, maybe we'll give you $1 million. And you say, that's a lot of money still, but that might only be enough to get a handful of observations. So you want to really design your study in order to maximize that stuff, right? And that's what 101B design of analysis experiments is all about, okay? On the other hand, we're kind of also at the same time, we're at a place where data is incredibly quote unquote cheap, okay? There's tons of information out there already, right? You can code up a little web scraper that goes out to websites and just downloads a bunch of text, tables, numbers, and all sorts of stuff, and you can go through, right? Like you can just design a little thing, and you can say, well, what are the most popular apps on the App Store? And you can design something that kind of goes through the App Store website, and it says this is approximately how many downloads it has, and this is the star rating, and this and that, and you can just design a little web scraper and download that, or you might be able to find something, and you can get tons and tons and tons of data. But then how do we handle that, right? You can't do work calculations by hand. You got to do everything by the computer. That requires some coding skills. And then it's also important to note that that data is not going to be a random sample. And I haven't even talked about what random sampling is, but for a lot of traditional statistics, the idea of a random sample is very important, but we're also we're kind of entering an era where the idea of a random sample is no longer an option. So can we still get meaningful information out of it? And we can do different kinds of analysis, different kinds of things, even though we don't have a random sample, right? And so I would say this is a big way where data science is different from traditional statistics. We're no longer depending on the random sample. You know, our goals are a little bit different, and perhaps we're in a time where we have maybe too much data and things like that, okay? There's kind of this Venn diagram. Drew Conway created this Venn diagram and said basically data science consists of coding skills, math and stats knowledge, and domain expertise. And so we said, so coding skills, he writes as hacking skills, okay? And math and stats knowledge and substantive expertise, and the overlap of these things is data science. And kind of, you know, if you're a stats major or data theory major, you're going to be required to take kind of a bunch of math courses, right? And these math courses will give you the theoretic foundation, or at least the theoretic and mathematical reasoning for some of the things that we do. When we say, hey, this is what the sampling distribution looks like, this is what the central limit theorem is, and this is why we calculate the variance this way, and the formula is this, you're going to kind of prove a lot of these things. That's going to be kind of done for you in the math part, okay? And if you take that and you combine that, say, with traditional substantive expertise, so let's say you're going to work with people from the psychology department, and you look at kind of these data sets, that would fall under traditional research. You take your stats experience, you know, the design of the experiments and the analysis there, along with understanding, you know, some of these principles, you get traditional research, okay? You introduce the coding skills, the hacking skills for these large data sets, that's when you'll kind of get into a little bit more data science-y type stuff, okay? So what happens if you take away the substantive expertise, okay? Here in this plot, it calls it machine learning, and it's kind of the idea that you can code and you can do math and stats, but then you have no real knowledge of whatever subject it is, and that's a dangerous place to be. So I mean, machine learning, it's a great thing, but you can't just take a machine learning algorithm and throw it at some data set that you're unfamiliar with, okay? So, for example, if you are from another country, okay, your grading system is not going to be this ABCD 4.0 grade scale, right? And so if you were just given some data without any context, and let's say these are people's grade point averages, and you wanted to do some kind of analysis, you would have no idea, is a 2.1 a good thing or a bad thing? Is a 3.9 a good thing or bad thing? Is a 4.7 or something, right? Like high schools have weighted things. Like you wouldn't, it would be hard to know, right? You need to be kind of familiar, and concepts like, you know, what's better, a 4.3 or a 3.99 or something, right? And you, even if you just hear that, right, you see, oh, 3.99, and then you got a 4.3 or something, you might wonder, oh, is that 3.99 weighted or unweighted, right? Like you automatically know, like these are some of the questions you need to ask, okay? Because you're familiar with the context of this information. But again, if you were from another country where you didn't have this grade scale, you wouldn't know these are the kinds of questions to ask or like these anomalies to pick out. And so your analysis will be severely hindered, okay? And you know, later on, I'm going to have you do a group project, and I'm going to say, you know, pick out a data set and things like that. And you go on the internet, there's going to be tons of data sets out there, right? And one popular data set out there is this wine tasting data set, okay? Now, I imagine, you know, some of you might be 21, or over 21, but even I doubt you are a wine tasting expert, okay? I doubt that we have very many wine tasting experts. And so I would say your analysis of a wine tasting data set is gonna suck, okay? Because you have no idea like what any of these terms really mean. Like somebody says, hey, what's the difference between a Cabernet and a, Chardonnay and, you know, Pinot Noir and things like that, and you'll just, you know. And so what are we looking for, right? Is it, you know, is the acidity level supposed to be high or low in this type of thing? Like you don't know, right? Whereas an expert would, right? And so to get real meaningful data science, we need to be able to combine that. Oh, okay, I'm like talking way too much. Okay, all right, so the textbook talks a little bit more about sabermetrics and how data science has really revolutionized baseball statistics. Like statistics has always been around in baseball for a long time, but we're really doing cutting edge stuff there. Let me give you your last viewing quiz answer. The third one for today is the letter E. E as in elephant. E as in elephant, okay? So I've kind of covered, I put in here, like these are the kinds of things that I want to cover. We'll cover like the tools using R and stuff like that. We'll look at theoretic foundations, and then we're going to look at modeling and things like that, okay? A couple things. How is this different from Stats 10? So Stats 10, I hate to say this, it's an easy class. This class is going to be a little bit more intensive, okay? And so, and everything in Stats 10 is kind of assuming that you're working with a random sample, and it comes kind of from that traditional thing. This one we're going to be using a lot more R and things like that. You'll be taking Stats 20, 1 and 2A, and that's going to be more focused on programming, R programming, and doing things with that. Whereas here we're going to be using R as a tool, but mostly for the purpose of extracting information out of the data, okay? And then classic question, why do we use R and not Python, okay? And the answer is well, that's what we've chosen. But Python is a general purpose language. It's an excellent language, but it's general purpose, whereas R is designed to work for statistics and data straight out of it was designed with that in mind. So there's a few things in R really well suited for it. And the RStudio interface, which is what we'll be using, is really also designed with data science in mind. And so they've got a lot of good things working there. And so I think it is a good choice. Okay, anyway, that's it. Welcome back to UCLA. I look forward to a great quarter with you guys. And we will see you guys on Monday. Have a good weekend. Have a good rest of your day. What's that? Yeah, I will upload these notes. I'll upload the video, and you'll see a lecture viewing quiz on CCLE. Okay?